This is part 4 of section 5.5. We want to solve tangent of 2x is equal to the square root of 3 over 3. And we want to find all the solutions between 0 and 2 pi. So I'm going to find inverse tangent of square root 3 over 3. And that would be pi over 6. So 2x is equal to pi over 6 plus, with tangent, it's n pi. And you only have one possible solution. We don't have the two possibilities with tangent. Now I need to divide everything here by a 2. So x is equal to pi over 12 plus 1/2 n pi. So to get all of my solutions, I need to start off with pi over 12. If my n value is 0, then I get pi over 12. If my n value is 1, then I am adding pi over 2, and you get 7 pi over 12. If our n value is 2, and you add pi over 2 again, then you get 13 pi over 12. If our n value is 3, then you add pi over 2 again, and you get 19 pi over 12. And if you add again, then you are finally above 2 pi, and so you have everything listed. Your 4 solutions are pi over 12, 7 pi over 12, 13 pi over 12, and 19 pi over 12. Okay, let's solve cosine of 2x plus pi over 4 is equal to negative square root 3 over 2. So first, let's find inverse cosine of negative square root 3 over 2. And that would be 5 pi over 6. So we have 2x plus pi over 4 is equal to 5 pi over 6 plus 2n pi, or 2x plus pi over 4 is equal to 2 pi minus 5 pi over 6 plus 2n pi. So here, if I subtract 2 of pi over 4 from both sides, we get 2x is equal to 7 pi over 12 plus 2n pi. And then if you divide everything by 2, we get x is equal to 7 pi over 24 plus n pi. Common denominator combined here, we have 2x plus pi over 4 is equal to 7 pi over 6 plus 2n pi. Subtract pi over 4 from both sides. 2x is equal to 11 pi over 24. Oh, sorry, not 24, 12, plus 2n pi. Now divide everything by 2, and that's where the 24 comes from. 11 pi over 24 plus n pi. So we have several solutions to come up with. If n is equal to 0 here, then we get 7 pi over 24. If we add pi to this, so if n equals 1, then we get 31 pi over 24 is another solution. And then if we add pi again, then we're too large. Here, if our n is 0, then we have 11 pi over 24. And then if we add pi to that, so if our n value is 1, then we have 35 pi over 24. And then if we add pi again, then we're too large. So those 4 solutions are all of them. Those are all of our solutions. Okay. So we have cotangent of x over 3 is equal to the square root of 3. This means that tangent of x over 3 is equal to 1 over the square root of 3, which is square root 3 over 3. Now, inverse tangent of square root 3 over 3 is pi over 6. So we have x over 3 is equal to alpha, which is pi over 6, plus, since it's tangent, it is n pi. And with tangent, we don't have a second set of possibilities. Now, I want just x, so I'm going to multiply both sides by a 3 to get rid of that. So we get x is equal to 3 pi over 6, which is pi over 2, plus 3n pi. So our solution is pi over 2, and then if we add 3 pi to that, we'll get another solution. And we add 3 pi to that again, we'll get more. But that, if we're adding 3 pi, that definitely makes it larger than 2 pi. So our only solution here is pi over 2. Everything else is outside of the range they ask us to do. Okay, so let's try cosine of 2x equal to cosine of x. This is the first time where we haven't had an actual numerical value to do. We have that x still in there. We don't have a number here. Well, one of the things that we did find out is that if one of your solutions you can get by just saying that this has to equal this plus your adjustment. So for cosine, I know that 2x has to equal x plus 2n pi. Or, so we're just treating it like x is our alpha. I have 2x equal to, since it's cosine, 2 pi minus x plus 2n pi. Okay. So now let's solve this for x. So subtract x from both sides here. And we have x is equal to 2n pi. Okay. Now here, if we move the x over to here, then we have 3x equals 2 pi plus 2n pi. And we need to divide everything by 3. So x is equal to 2 pi over 3 plus 2/3 n pi. Well, here, if our n value is 0, then our x value is 0. And if n is 1, then we have 2 pi, and we're not supposed to, our solutions are supposed to be between 0 inclusive and 2 pi with a parentheses, so not included. So 0 is the only solution we get from this set of possibilities. Here we have if our n is 0, then we have our x value is 2 pi over 3. If our n value is 1, then we take 2 pi over 3 and add another 2 pi over 3, and that gives us 4 pi over 3. And then if we add 2 pi over 3 again, then we are at 2 pi, which is beyond the range we are looking for. So here we have three solutions. We have 0, we have 2 pi over 3, and we have 4 pi over 3. Okay, let's do something similar here with sine of 2x minus pi over 4 equal the sine of x. So we know that 2x minus pi over 4 is equal to x plus 2n pi, or 2x minus pi over 4 is equal to, since this is sine, it's always pi minus our alpha, which is our x, plus 2n pi. Now solve this for x, so subtract x here. You're going to add pi over 4 here, and you get x is equal to pi over 4 plus 2n pi. Okay. Here, if I add an x here, I get 3x equal to pi plus pi over 4 gives me 5 pi over 4 plus 2n pi. Now I need to divide everything here by a 3, and that gives me x is equal to 5 pi over 12 plus 2/3 n pi. Okay, now here if our n is 0, then we get pi over 4. And then if our n is 1, then we're adding 2 pi and we're outside of our range. For this one, if our n is 0, then we have 5 pi over 12. If our n is 1, then we add 2/3 pi and we get 13 pi over 12. And then if our n value is 2 and we add 2 pi over 3 again, then we get 7 pi over 4. And if we do it again, then we are too large.